1.5b is about even and odd polynomials. All right? So, even functions, if you look at these examples, they are symmetrical over what, do you think?
Y.
The y-axis. They are symmetrical over the y-axis, and so like if I drew a line down here, this dot would reflect over to that dot, same thing here, y-axis. This dot goes to this dot, easy, right? Yeah? Okay? And then odd, what do you think odd would be?
X-axis.
Yeah, you'd think, but it's not. Good job, Capri.
Oh,
Here.
embarrassing, you guys. Oh, you can't be a sorbet.
No, I know. Okay, so yes, you'd think it would be over the x, but it's not. It is, so look it, if it was over the x, this dot would go up there, wouldn't it? If it was over the x. So what do you think it's over?
Like the hurt.
The zero, what's that called?
The origin.
point of
The origin. Perfect. The point of origin, 0, 0. Here, Isabel. So like this, it goes around the point of origin. Okay, so one thing you can always tell, okay, is if they want you to graph it, okay? Let's pretend that this point is 1, 2. So if I have a point, x, y, it is going to go to, what is this point?
-1.
-1, 2. So it's going to, so what happened? Michael? What happened?
It reflected the X.
The x changed and then the y stays the same. So that's how they kind of write it. They say you would change. So if this was negative, it would be a double negative. It would be negative, negative, which would make it positive. Okay? And then the y stays the same. If it's negative, it stays negative. If it's positive, it stays positive. And then down here, what would this be? So if this was, let's say this was 2, -2, what's this?
Positive 2,
Negative 2, 2. So what happens to my x and y?
They switch.
They switch. Fantastic. Both switch. Was that you, Miriam? Or Isabel?
Bro!
Ooh.
Thank you. That's my second move.
Tell me next
Oh,
time and then
we're
I'll
correct?
do it like that. Tell me and then I'll, yeah. Okay? So if I wanted to, this even function right here, if I had to graph the other half, okay, it is symmetric over x equals 0, which is the same as the y-axis. Okay, so if I wanted to draw this, it'd be pretty easy, don't you think, to make your dots to draw? Like, I feel like when you're just reflecting over, it's kind of easy. This analytically, okay, what it means is if you take the function and you put in a negative x, you are going to get out the original function. Okay, that's kind of weird and that kind of throws people off. Okay, so let me show you how this works. Okay, so what this means, what this means is if you have, so they're going to ask you, is it odd, even, or neither? Okay, you have 3 choices. You can do the same exact thing for all 3 choices. Okay, and what you are going to do is you are going to substitute in a negative x. Okay, so the rule is you have this equation. You have this equation. So I have f of x equals x to the 6 minus 4x squared. Okay, they're going to give you some random polynomial. All right? And what you have to do is instead of x, I need to put in a negative x. So everywhere you see an x, you're going to put in a negative x. And what that looks like is, like I would, instead of this x right here, I'm going to put in parentheses a negative x. I keep the 6, and then I keep the minus 4, And then instead of this x, I'm gonna put in a negative x, and I keep the squared. And you put the negative x in parentheses. Okay, so do you see what I did? I just am taking out the x and putting in a parenthesis with a negative x. Okay? Now, you do this, you do the operation, and whatever you get out at the end will tell you if it's odd, even, or neither. Okay? So, what is negative x to the 6th power?
1 over x.
That would be if it was negative 6.
Oh,
Like if the negative is up there, that becomes a fraction.
6x.
So you have 6 of them.
So negative x to 6 power.
So 2 negatives make a positive, and these two make a positive, and these two make a positive. So what would this be?
Positive x to the
Positive x to the 6th. The negative kind of gets rid of itself because there's an even amount of them. Does that make sense? Because there's 6 of them. Because if you were to write that out, it would look like negative x times negative x times, like, oh my gosh, I'm getting like, yeah. Okay? And then what about this? So PEMDAS, you have to do exponents first. So what's negative x squared? X squared, and then so it would just be minus 4x squared. Okay, so now you have to look back up. So now you're going to take this answer and you look back at the original. Okay? And what this is saying is if you put in a negative x, do you get out your original function? Do you get the same exact thing? Okay? And x to the 6 minus 4x squared, x to the 6 minus 4x squared is the exact same. So that means it's an even function. What's another like shortcut? Does anybody see one? Isabel?
Just looking and seeing if it's even exponent.
Yes, if you look, 6 and 2, since they're even amounts of negatives are going to always make it positive, aren't they? Okay? So that kind of is a little trick that you can use. All right, so if we go to odds,
Wait, what should we put on in the sentence?
oh, I'm sorry, it's same. You're going to get the same, you get the same original function. Good catch, Jacob. You want a Jolly Rancher?
Sure.
What color?
Green.
I think you're the only one to say that.
That's insane, Jacob.
Okay,
Choosing green?
odd functions. Odd functions are, let's say I'm going to still put in a negative x. I'm going to still put in a negative x into the function. Okay? But my answer is going to change everything in the function. Okay? So it's going to make the entire function the opposite sign. Okay? So if I wanted to do these points, so let's say this point is 1, negative 2. I'm going to change both signs to be negative 1, positive 2. Let's pretend that this is 2, negative 8. I have to change both signs to be negative 2, positive 8. And then you'd be able to redraw it. So what this looks like for this next problem is you're still substituting in negative x, but you're going to get the opposite of the function. So do you see how this right here has 2 parts? Okay, it has a negative 2x to the 3rd and then plus a 5x. Both of those things have to change. So that has to become positive and that has to become negative for it to be odd. So how you prove that, okay, is I'm going to put in a negative x. So I'm going to rewrite negative 2. That doesn't change. I'm going to make this into a negative x to the 3rd. and then plus 5, and then a negative x. So I just took the x out and plopped in a negative x. And then I gotta try and like solve this. So negative x to the third, since there's 3 of them, what's gonna happen?
It's going to be negative.
It's gonna stay a negative, right? What's a negative times a negative?
Positive.
Positive 2x to the third. And then what does this one become?
Wait, isn't the x still a negative then?
Yeah, so this, once you do that,
Oh,
nothing's
yeah,
really
yeah.
changing.
Sorry. I'm sorry.
And then you times it by this negative, yeah. And 2 negatives make a positive, and then a positive and a negative make a negative. So now look, did the 2 change? Yes, it went from negative to positive, and then the 5 went from plus to minus. So this is an odd function. There's a one on the example where there's like a solid whole number. That also has to change. Like if it's a plus 10 and you get a plus 10 here, that would throw your whole thing off and you would be a neither. Okay? So if you look at the next one, why don't you try that on your own? See if you can do that one.
I haven't done that.
Even, odd, or neither. Oh. Okay, now prove it. You are right. Okay? So Isabel said neither because there's a 4 and there's a regular 1. But then they're going to ask you like to prove it. So you would put your negative x in. And this is going to become positive, so that stays the same, right? And then a negative times a negative makes that a positive. So look what happened. 6 stayed the same, but then the minus 2x became a plus 2x. So if everything doesn't change, it's just neither. Easy? It's okay so far?
Yeah.
It's not that bad? Okay. One last thing. There's a lot of mumbo jumbo here. Essentially, what this says is you have a polynomial in this form. And what that form, here's an example. A whole number like 7 and then x to like the 5th power. When n is greater than 1, if n is even, it's an even function. If it's odd, it's an odd function. So this number right there determines your function. And it only works if it's 1, if it's a monomial. Okay? So what would this first one be? Odd. Why? Because of the 3. But you can also use the handy dandy put in a negative x thing. Okay? If I put in a negative x, I would have negative 10 times negative x to the 3rd. That becomes a negative x times a negative 10, so that's going to become a positive 10x to the 3rd. And since it changed, it's an odd function. You can still use the proof. Okay? What about the next one? Even. Sasra, do you want one? Oh, I thought it was you.
That's what it's.
What color?
Blue.
Blue, please. Even?
Sure.
Perfect. Even. And then last one?
Even.
Even because of
Oh,
the
that-
6.
yeah, makes sense.
Was that you, Gavin?
That makes sense.
Yeah.
No. Okay, I'm hearing things.
Wait,
Yes.
so if it has an even in and odd, then it's matter? So it has to be fully even. Have to have a single one.
But when in doubt, just plug in your x. And yeah, if you have to prove it. So there's quite a bit of practice, but remember, you only just need to do the practice. And